In the previous video lecture, we have seen about the architecture of 8086 microprocessor. So in this video lecture, we are going to see the addressing modes of 8086 microprocessor. So before we proceed to the addressing mode, first we will see or first we will recollect the physical address calculation of 8086. Okay. So just remember the addressing bus, the address bus of 8086 microprocessor is of 20-bit. But when you see the memory ICs, each and every location is mentioned or addressed with 16-bit hexagonal values. So this 16-bit address has to be transferred into a 20-bit address value. This we have seen in the architecture itself, how it is transferred from 16-bit to 20-bit. Once again we will recollect it. Fine. So if this is your memory, so the 8086 microprocessor is capable of addressing 1 megabyte of memory. So how we have derived this 1 megabyte? So 2 power 20, nothing but 2 power address bus will give you that 1 megabyte addressing, memory addressing capability. Okay. So this 1 megabyte of memory is splitted into 4 segments: data segment, code segment, stack segment and extra segment. Okay. So these memories are equally splitted. Fine. Okay. So each and every segment will have its starting address. Okay. So this starting address is mentioned in the segment register. This you know already. Fine. Okay. So this locations, each and every location of data segment, stack segment and then extra segment are mentioned by the 16-bit address value will be like this. So this is a 16-bit value, no? Okay. So each and every location will be mentioned like this with a 16-bit value. We have to transfer the 16-bit into 20-bit. Fine. So how it is transferred? You have to multiply 10 with the segment register. Okay. Then you have to add the offset value. Fine. Okay. So this part we can do in 2 ways. One, you can multiply with 10. So or else you can shift this register value to 4 bits. Okay. 4 bits left side. Okay. So take this value as an example, 5500. So in the first way, if we multiply with 10, we will get 55,000. So now we will follow this one. Okay. You have to shift this value to the left side, by 4 bits. Okay. So what's the binary value for 5? 0 1 0 1 0 1 0 1 0 0 0 0 0 0 0 0. So this is a 16-bit value. If we shift this towards the left, what we will get? This 4 will come here in this place. 0 0 0 0. Okay, 0 0 0 0 1 0 1 0 1 0 1 0 and this place 0 will be added. So as a whole, this is a 20-bit value. Fine. So with this, when it multiplied with 10, after it is multiplied with 10, we will add the offset value. So what is offset value? So this is nothing but the in-between memory locations of the segment registers. We will know only the starting address that is mentioned in the segment register. The in-between addresses are known as offset values. Fine. So with this note, we will start up with the addressing modes. Okay. So in 8085 addressing mode itself, we have said that what is addressing mode? The way of representing the operands and the operation has to be done is known as an addressing mode. Fine. Okay. So there in 8085 we are having 5 addressing modes. Here we are having 11 addressing modes. So most of the addressing modes are similar. The concept is similar. Quite of the addressing mode will get deferred. We will see what are all they. Fine. Okay. So we will see the addressing mode one by one. The first addressing mode is immediate addressing mode. So what do we mean by immediate addressing mode? We have to, if the operand is mentioned in the instruction itself, that kind of instructions are called as immediate addressing modes. Fine. If the operands are nothing but the data, if data mentioned in the instruction itself, so though if the operand are mentioned in the instruction, that kind of addressing mode is called as immediate addressing mode. Fine. Okay. So I will take an instruction as an example. Move instruction we will take. Okay. So here the instruction format will be like, for example, move. What move will do? It will transfer a value from one register to another register. Okay. It will just transfer the value. Here first we have to mention the destination, second we have to mention the source. Okay, this is the format that we will use here. Okay, so all the registers, the values that we use here are 16-bit. This you will know already because 8086 is a 16-bit processor. Fine. So for example, I will take this. Okay, move bx, 526a. Okay. So here this is the value that has to be transferred to the register bx. Okay, the value is mentioned in the instruction itself. So this kind of addressing mode is immediate addressing mode. Okay. The second addressing mode is register addressing mode. Okay. So here in register addressing mode, the operand is mentioned in a register and that register is mentioned in the instruction. Fine. So for example, we will take the previous example itself. Fine. So in the previous example, we have moved the immediate value 526A to the register BX. But in case of register addressing mode, the operand is mentioned in the register. Okay. So for example, we will take the same value. We will place that value 526A in CX register. Then in instruction we have to write like move BX, CX, which means that the value in CX register is transferred to the BX register. And this is how the register addressing mode look like. Fine. And third addressing mode is direct addressing mode. So direct addressing mode, the operand's address is mentioned in the instruction. Okay. In the previous two addressing modes, operand itself is mentioned in the instruction as a case of immediate. Operand's register is mentioned in the instruction, that is register addressing mode. Here the operand's memory location is mentioned in the instruction. So this kind of addressing mode is called as direct addressing mode. Okay. Operand's address is mentioned in instruction. Okay. So if this is your memory, fine. So this is here we are using the operands. Here we are using the operands. Fine. So operands will be stored in data segment or else in the extra segment. We will take data segment. Okay, fine. So in the data segment, the value 65252 is given and the address of this 5252 is 3200, for example. Okay. So in case of direct addressing mode, it will be like move, okay, bx, 3200. Fine. So this is of the instruction will look alike. Move bx, 3200. Here we have to mention the bracket. Why the bracket is mentioned in the sense, if we represent without the bracket, it will be like a 16-bit immediate value. Okay, fine. But here the 3200 is not an immediate value. It's an address of the operand. Fine. So to differ the address and the operand, we have to mention the address with the square bracket. Fine. Okay. So here the address value is 16-bit. We have to transfer this to 20-bit value. Okay. We already know how this transfer take place. 10 into segment register plus offset value. Fine. Here the segment register, in this example we have taken the data segment, so we have to take the value in the data segment value. So for example, if the data segment is with the value 5000, fine. So then how the effective address will be formed? 10 into 5000 plus offset value. So the offset value is nothing but that we have mentioned here in the instruction itself, 3200. Then now it will be 50,000 plus 3200. This will be 53200. Okay, this is the effective address. Once the effective address is framed, your processor will go to that location 53200 and take that value and then place it in the BX register. So, and this is how the operation will take place. Fine. And the next addressing mode is register indirect addressing mode. So, in this, the address value, operand's address is mentioned in the instruction. Okay, that is direct addressing mode. In register indirect addressing mode, operand's address is mentioned in the register and that register is mentioned in the instruction. Okay, so we will see an example. Register indirect addressing mode. Okay, here operand's address is mentioned in the register and that register is mentioned in the instruction. Okay, fine. Here the example will be like move AX comma CX. Fine. Here AX is a register which has the operand's address. Okay. So that's why we have mentioned the register with the square bracket. If the square bracket is not there, then it will be like the register addressing mode. Fine. So here we have mentioned the square bracket, which means that the value in the AX register is the operand's address and not the operand. Fine. So here also we have to frame the effective address, and how it is framed is, so 10 into segment register. The segment register that we use here is data segment plus we have to mention the offset value. So the offset value is now stored in the AX register, then we have to AX. So for example, if data segment is having the value 6500 and AX value is 5500, then 10 into 6500 plus 5500. Okay, so this is how the effective address will be framed. So what the processor will do now, data segment, each and every location, the value in CX register, okay, the value in CX register will move to the address that we have framed, the effective address. So this value will be transferred to this effective address. Fine. So this is how the register indirect addressing mode will work. Okay. So in the register indirect addressing mode, operand's address is mentioned in the instruction. Here also the same, the operand's address is mentioned in the register and that register should be a source index register or destination index register. Okay. So either of these two registers only we should use in indexed addressing mode. Fine. So for example, it will be like move CX comma SI. Okay. So SI is nothing but source index register which has the operand's address. Okay, so here also the effective address formation is same, 10 into segment register plus offset value. Okay, so here the segment register is data segment, offset value is index registers value. For example, if the value is 5000 and SI's value is 326A, then it will be like plus 326A and you will get 5236A. Okay, so how this operation will take place, you will have your memory and this is your data segment and the location is 5326A. the value in this register, okay, in this memory location is now transferred to CX register. Fine, now you got it. In the previous addressing mode, operand's address is mentioned in the register. That register could be a general purpose register. Fine, but here in the case of indexed addressing mode, we are supposed to use the offset value will be stored in the indexed registers. Either it can be source index or destination index register. Fine. So, and the next addressing mode is based indexed addressing mode. Okay, I will explain you this with an example. Here we will take same move CX comma. So based in the sense we are supposed to use any of the base registers. Okay, so the base registers are BX. The base registers are BX, another one is BP. What is BP? It is base pointer. Fine. So either of these two registers we have to use here. So we will take base pointer and then index register. So either of the index register, source index or destination index. So we will take destination index register. So what will happen here? The address framed by these registers, okay, the value in the address framed by these registers is transferred to CX register. Fine. So we will frame the effective address now. The data segment value will be like 5000. For example, I am taking BP value is 3200. Okay, source index value is 400. For example, I am saying how the effective address is framed here, 10 into 5000 plus offset value we have to add. The offset value is given by these two registers. One is 3200, another one is 4000. So this will be the offset value. And what value we will get? 600. Fine. So this is the effective address. Okay. Your memory data segment in this location, the value in this location is now transferred to CX register. Okay. So in the previous, compared to the previous, the formation of the effective address is getting deferred. Okay. So previously in register indirect we have used general purpose register for framing the effective address. Okay, the offset value is stored in the general purpose register. In previous indexed, the offset value is stored in the index register. In this example, the offset value is framed by base address and then the indexed addressing mode. So that is getting deferred. The formation of the effective address is getting deferred. Fine. And the next addressing mode is relative addressing mode. So here also I will take the same move example. Fine. So here what the difference is? Okay. So the value in CX is moved to the address framed by this thing. Okay. So what is the 50 here? So this is nothing but the relative displacement. Okay, we are mentioning the displacement value here, and how the effective address is framed in the sense, obviously we will take the data segment. If its value is 5000, bx value is 4500, then the effective address formation will be 10 into segment value 5000 plus bx value 4500 plus this displacement. Okay, so this will give you the offset value, and this 50 is displacement. Okay, and that displacement is mentioned in the instruction. Fine. So what the final value will be? 54550. Okay, your memory data segment, this is the address. Okay, if CX register is having the value 6500 and that value is transferred to this location. Okay, the effective address formation is getting deferred in each and every addressing mode. Okay, that's all the difference. Okay, don't get confused for these things. The effective address formation is getting deferred. That is the only thing here. Fine. Okay, so the next addressing mode is relative based indexed addressing mode. Fine. Relative based indexed addressing mode. Okay, so based addressing mode, we already know that the offset value is framed by index register and base register. So here the relative value, that is nothing but displacement, is added here. Fine. So for example, it will be like move ax comma 60, it's a hexa value. Fine. 60 bx si. Okay, so this will give you the offset value. Okay, so once the effective address formed, the address value is transferred to AX register. Fine. So if data segment is having the value 6000, bx is having the value 3500, then source index is having the value 4000, then the effective address will be like 10 into register value data segment. Okay, then bx value, then index value, and then your displacement that we have mentioned in the instruction 60. So as a final, what value we will get? 69560. Okay, if this could be your memory, your data segment, and the address. Okay, this is the address of this location. The value here will be 5500. This value is moved to the AX register. Fine. The effective address formation is getting deferred. That is the difference. That is the difference for each and every addressing mode. Fine. So on the next addressing mode is intra-segment addressing mode. Intra-segment. Okay. So there is two such kind of addressing modes. One is intra-segment, another one is inter-segment. So these addressing modes we will use only for the branch instructions. Okay. So what are the branch instructions? Yes, jump instructions are called as branch instructions. So this we have seen in 8085. Fine. Jump instruction, when we will use jump, if we want to transfer the control of the processor from one location to the another location, we will use jump instruction. Fine, correct? Okay. So here first we are going to see about intra-segment. Fine. So what is intra-segment? Inside segment, right? That is the exam, that is the meaning for intra-segment. If the transfer has to be, that means process control has to be transferred to the same location, same segment, but to the different location, we have to use intra-segment addressing mode. Fine. So for example, we will take the memory. Okay, we will take the data segment as an example. Okay. So initially your processor is accessing the addressing mode 2000. Fine. Now you want to jump to the 3000 address. Then you are supposed to use intra-segment addressing mode. You are jumping inside the segment. In the same segment only you are jumping. At that case you have to use intra-segment. If you want to jump from data segment to extra segment, fine, from data segment to extra segment, you are supposed to use inter-segment addressing mode. So that is the difference between intra-segment and intra-segment. If you want to jump to the same segment, you have to use intra-segment. If you want to jump to the different segment memory, I am mentioning that, fine. So another segment you have to use inter-segment addressing mode, fine. So in intra-segment you can mention the jumping address by two ways. One is direct, another one is indirect. Okay. So if you mention the jumping address as in the instruction, that is direct addressing mode. Example, jump 3000. So here the jumping address is mentioned in the instruction itself. In indirect addressing mode, the jumping address is mentioned using an register. That is the difference. Here the BX register will have the value 3000. Okay. So mentioning the jumping address is getting deferred. So this is like then intra segment will also like intra segment. Okay. Okay. So this is also mentioned in two ways: direct, indirect, and that is also like same. If the jumping address is mentioned in the instruction, that is direct. If it is mentioned using a register, that is indirect. Okay. So that's all. Fine. So these two addressing modes we will use only for the branch instructions. Okay. So unto unconditional. Okay. Unconditional branch instructions only we can use these addressing modes. Fine. Okay. So we will summarize today's video. Okay. So what we have seen today, we have seen the addressing modes. Here we are having 11 addressing modes. Okay. So each and every addressing mode is differed only by framing the effective address, how the effective address are framed. Okay. Based on that the addressing modes are differed. Fine. The first addressing mode is immediate, where the operand's address is mentioned in the instruction. Then register addressing mode, where the operand's register is mentioned in the instruction. And next we have seen the direct addressing mode, where the operand's address is mentioned in the instruction itself. Okay. From there itself we are supposed to calculate the effective address. Fine. And the next is register indirect addressing mode, which is nothing but operand's address is mentioned in the register and that register is mentioned in the instruction. Fine. The example. So the example that you have seen for register addressing mode is move AX, CX, where the AX is having the operand's address. Okay. So this operand address is used as an offset value. Fine. And the next addressing mode that we are seeing is indexed addressing mode, where we have used the index register to store the offset value. Fine. In previous example we have used the register, general purpose register to store the offset value. Here we have used the source index. And the next addressing mode is based indexed addressing mode, where the offset value is framed by using a base register and the index register. Fine. From that we have calculated the effective address. And the next addressing mode is relative. We have mentioned the displacement in the instruction. Using that we have calculated the effective address. And the next addressing mode is relative based indexed addressing mode. We have mentioned the offset value is calculated using a displacement, a base register and indexed register. And the last addressing mode that we have seen is intra-segment and intra-segment addressing mode. Fine. Okay. So this is what is about the addressing modes of 8086 microprocessor.